Please join me in welcoming Professor Madhavan Rajeevan, Vice Chancellor of Atria University, former Secretary of MOES, who will enlighten us with his public address on the impacts of climate change on the Indian monsoon. Over to you, sir.
Good evening to all of you, and I'm extremely happy to be here in Goa and to address the public lecture on impacts of climate change on Indian monsoon. So I should thank Honorable Vice Chancellor of Goa, Professor Harilal Menon, for inviting me for giving this talk. And I should thank Professor Ifam Nadaf, Dr. Chandrasekhar Rivongar and Dr. Elizabeth Henriques, Madam, for making all these arrangements, and so that I give a public lecture at this wonderful auditorium, addressing young students as well as public and scientists, young scientists from different students from different colleges and universities. So I will talk about impacts of climate change on Indian monsoon. So I'll be talking basically on these topics. This is the area where I'll be outlining my presentation. I'll first introduce what do you mean by Indian monsoon and what are the characteristics of Indian monsoon, and what is also the basics of climate change. You people will be hearing about global warming, climate change, etc. So what really it means. So I'll be talking about that. And also I will talk about what are the changes we have seen so far in monsoon and what will happen in future projections. So we call future projections of monsoon. And if climate change is happening, what we can do, we common people or government, what we can do in terms of adaptation as well as mitigation measures. So I'll be talking very basic, so I'm very sure that you'll be able to understand and appreciate. And so basics of monsoon, you know that we are in the northern hemisphere, so December, January, February, for example, is a winter season for us. So temperature, we know it's a winter season, cold season, temperatures are very cold. And so left hand side, what you see is the temperature distribution. In the over Indian mainland, temperatures are cold, but over the ocean, southern Indian Ocean, especially southern Indian Ocean, is warm. So, but when you go for May, June, July, things are just reversed. When sun comes northern hemisphere, so land surface temperature gets heated up much faster than ocean, because physics students maybe know that the so-called term called heat capacity. So land has a lower heat capacity compared to ocean. So land gets heated up much faster than ocean. So the temperature gradient just gets reversed. Warmer temperature over land and cold temperature over ocean. When temperature gets reversed, automatically the pressure also gets reversed. In the winter season, pressure gradient means from higher pressure to lower pressure, is from north to south, whereas in the monsoon season or summer season, it is from south to north. So low pressure over northern parts of India, central parts of the Indian subcontinent, and higher pressure over Indian Ocean. Because temperatures are higher over land, so surface pressure is low. So when pressure gradient goes reverse, automatically wind also gets reversed. And then the winter season, the winds are basically easterly or northeasterly, north to south. Whereas in month of July, for example, during monsoon season, you get winds from southwesterly winds. So the summer monsoon season, sometimes we call southwesterly monsoon also. And winter season, we have a small monsoon over Tamil Nadu, Kerala, and Andhra Pradesh, and that we call northeast monsoon. The winds are northeasterly. Whereas in monsoon season, June, July, September, the winds gets reversed, and we have so-called southwest monsoon. You can see the winds coming from southern hemisphere and crosses the equator and just flows across India. So this is the monsoon, beautiful monsoon flow. And this happens every year. In no year we say we can expect that monsoon will not come. Monsoon will come. So it's a large scale pattern, physical process which will happen every year. Only question is the delay in coming and going, and that kind of things, there can be year to year variation, but every year monsoon comes and goes. And there are theories of monsoon theories, why the monsoon should be. As I said that the temperature gradient is the driving force for monsoon. So we call the first theory by Halley, he's a scientist from England. So he proposed that it is a gained sea breeze coming in the airflow coming from sea, going to the land, and then coming down, up and going. It's a kind of a gained sea breeze. And Hadley has accepted the theory, but then he added one more parameter called Earth's rotating. We know that Earth is rotating. 24 hours it just rotates its own axis. So when the wind flow from southern ocean to northern ocean, the winds get deflected towards the right. So we get, instead of a southerly flow, we get southwesterly flow. And Webster, he said that it's basically the heating of the cloud. The cloud formation is very important for monsoon circulation. And if you really see the annual cycle of precipitation, the top figure shows how the rainfall is confined. You can see most of the rainfall is confined close to equator, and it's a kind of east-west direction. And when June, July, September, you can see the Indian region, you can see that the whole rainfall belt has moved north. And whereas in Pacific and all, the rainfall belt is still confined close to equator. So monsoon region, there are not only one monsoon region. We have monsoon in different places. We have monsoon in Africa, North Africa. We have monsoon in East Asia, including China. We have monsoon in Australia. We have small monsoon in South America. So wherever monsoon climate is there, this northward propagation or southward propagation of these clouds happen. And that is seen in the right hand bottom figure. You can see that so-called the cloud pattern or rainfall pattern, how it is shifting. The shifting is happening where the monsoon climate is happening. So this is a global monsoon region. So it's a common definition. Wherever the red dots are there, they are monsoon climate. There is one Indian monsoon, there is East Asian monsoon, there is one West North Pacific monsoon, there is one South American monsoon, South African monsoon, Australia, North Africa, North American monsoon. And if you ask me a question, out of this all monsoon, which one is the most important or most powerful? The answer is Indian monsoon. Indian monsoon is more important, and also it's more complex, more powerful system, climate system. And monsoon climate is, as seen, it's available, is notable in tropical Asia, Australia, Africa, America, and the Indian Ocean. Covers roughly half of the tropical region, and it hosts 65% of world population, mainly because of population from India and China, because we both of us have monsoon climate, so 65%. So monsoon is a very important, not only for India, many other countries, monsoon is very important. And if you ask me a question, how much monsoon rainfall we get, the answer is during June to September we get about 87 centimeter of rain, 87 centimeter. And we get some rain in October, November, December, some rain in January, February we get. So if you add it together, you get about 110 centimeter. That's about 1 meter. And what is the significance of 1 meter? What do you mean by this 1 meter rain? I'll explain to you. If you assume that whatever rain comes into the Indian region, Indian mainland, subcontinent, assume that it doesn't flow out to the sea. And also assume that there's no evaporation. So at the end of the year, we'll have about 1 meter of water spread throughout the country. And you can just guess how much water we get. 1 meter height of water and spread over throughout country uniformly. So you can just think how much water we get. Plenty of water we receive it during monsoon season as well as other small winter season also. And so we are fortunate that we have a monsoon season. And frankly speaking, we are all doing well mainly contributed by monsoon rainfall. So monsoon rainfall is, water is very important for any country to grow, for economic growth. And that is explained, this is how the rainfall pattern is during monsoon season. You get maximum along the west coast. Goa is the place where you get maximum rainfall. So you are lucky that you have plenty of rain you get. And also northeast you get a lot of rain. And eastern parts of central India gets a lot of rain. But if you go westwards, Rajasthan and all gets very less and less rain. And also in the southern parts of Tamil Nadu, also they get very less rainfall. And why monsoon is very important? So this is we call scatter plot. We say monsoon rainfall is related to Indian GDP. Now monsoon rainfall is important for many sectors. For example, the rainfall is required to fill up the dams, and that dam water is used for agriculture. Some dams are used for generating electricity, hydroelectricity, and so that is water resources management. And farmers need water, so rains, and mainly their agricultural practices, operations are completely dependent on rains. Almost 50%, half of Indian agriculture, the farming land is rain-fed area. The agriculture is grown where rain is there. If rain is not there, the agriculture output will be reduced. Of course, places like Punjab, Haryana, western parts of UP, they have irrigation. So even rain is not there in particular year, they will manage it because they have irrigation projects. But almost 50 to 60% of places, irrigation is not there. They completely depend on monsoon rainfall. And of course, Haryana, Punjab, the irrigation is, one way it is good that they can protect the agriculture, but it is really harmful because the groundwater depletion is happening. Whatever water is available, they are pumping out and putting it outside for agriculture, and so the groundwater is getting reduced every year, or especially over Punjab and Haryana. But agriculture, the rainfall is more important for agriculture, means it's more important for Indian GDP. Earlier, about 20 years back, agriculture had a big role in Indian GDP. Almost, it used to be 50% of Indian GDP used to come from agriculture. Now that is reduced now, because it's more of from service sector. They contribute more to Indian GDP. Agriculture contributes still about 15 to 16% of rainfall. So if agriculture is affected due to bad performance of monsoon, it can affect GDP. And this plot shows that if there is a drought particular year, it can pull down India's GDP almost by 2 to 3%. So that's an observation which we see. So monsoon is very important, and we are lucky we are in a place where we have monsoon. So we all should thank God that we have monsoon. Now I will come to climate change, basics of climate change. In our Earth climate system, we have 5 spheres. We have an atmosphere, we have a hydrosphere. Hydrosphere is nothing but ocean, lakes, water, basically water, rivers. It's all put together, we call it hydrosphere. Lithosphere is nothing but the core Earth. It's about 6,000 kilometer core Earth. Then we have a cryosphere. Cryosphere is nothing but snow, ice, sea ice, etc. Biosphere is, as you know, it is basically forest and vegetation, etc. So we have 5 spheres of everything put together. We call Earth's climate system. And but all these 5 spheres are not independent. They all interactive. So any changes in one component can affect the other component. For example, any changes in the atmosphere can affect ocean. Ocean change can affect atmosphere. Or cryosphere changes can affect atmosphere, etc. Biosphere can change. Any changes in the biosphere. For example, if you remove forests, it can affect the atmosphere. So these are some of the interactions which happen in the real world. So from where we get energy? We have to survive. So we need energy. So for example, if you want to drive a car, you have petrol. So that's energy. To drive a car is driven. Similarly, to our Earth system to sustain, you need energy. So energy comes from sun. So, and we are our planet is Earth is positioned in such a way that we get enough energy so that we sustain our life. So energy coming from sun is the main source of our energy. So, but if you keep on receiving energy, we will get more and more temperatures, so we will not able to survive. So what the real world, what will happen means, if you receive some energy, the same amount of energy is given out. So Earth system also gives the same amount of energy out to space. It loses some energy. And then the energy received from sun and energy going out of from the Earth system is same. For example, if X amount of energy is received from sun and X amount of energy is going out, then we call there is an equilibrium. Temperatures are, so then the temperature will be same. Temperatures will remain same. But if you assume if the energy going out is reduced due to some reasons, then what will happen? We will get more energy from sun. So then we get excess amount of energy that will ultimately cause a global warming. So the whole process of global warming is just nothing but we receive more energy than what we send back to outer space, our system. So the energy going out to the outer space is little less than what we receive from sun. So we have excess amount of energy in our system, and that leads to our so-called global warming, increase in surface temperatures, etc. And why the energy from our space, our Earth system going to outer space is reduced? The reason is there is a phenomenon called greenhouse effect. So some science students must have learned it. And so greenhouse effect is nothing but, you must have seen in some big agriculture farms, we have this kind of structure, the right hand side, where the agricultural plants are put, and it's a very warm place. How they maintain this warm place is the solar energy through these glass doors, it comes inside. But because the structure of the glass, the energy from the inside the system will be reduced, will be cut off. So the inside the house, the temperatures are much warmer. So they receive more energy than the energy which is going out. And this phenomena has been studied by many scientists starting from 1827. And why that greenhouse effect is happening is mainly because in the atmosphere we have greenhouse gases, water vapor, carbon dioxide, methane, ozone, nitrous oxide. These are the greenhouse gases. So these gases has a kind of affinity. These gases will allow the solar radiation to pass through the atmosphere and reach us at the surface, so we get enough energy. But carbon dioxide, all these gases won't allow the long way out, so the energy which is going out of the system, it traps some energy and re-radiates, and some radiation comes back. That's why these gases are called greenhouse gases. Out of that, water vapor is a natural gas, natural greenhouse gas. Whereas carbon dioxide, methane, ozone, nitrous oxide, the concentration of these gases can be increased due to our human activities. For example, we have industries, we have deforestation is happening, we have public transport, so we use a lot of petrol, diesel, etc. We change our land use. All this process basically increase the concentration of carbon dioxide, methane, nitrogen, nitrous oxide, ozone, etc. So how we know these changes are happening? So we have observation. So we say that we have a climate system, global observational network. So we have plenty of observational network we have. Basically it starts from satellites. We have plenty of satellites, and we have aircrafts. The aircrafts which are, for example, aircraft is going from Bombay to Delhi. Bombay to Delhi. So that the aircraft will be taking observations and sending it to meteorology department. Similarly, we have balloons. With balloons, we can take observations. It goes up to 35, 40 kilometers. We have surface observations. We have surface observatories. Over the ocean, we can put drifting buoys, and where we can put sensors, temperature, humidity, etc. We have ships. There are a lot of ships are plying, so ships take observations. All put together, we have plenty of observations. And satellite is the main source of observations. And these observations are going on years together. So we can collect these observations and analyze it and see how the observations, how our climate is changing. how this our carbon dioxide, so how people will ask you a question, how you know the carbon dioxide and methane and nitrous oxide, these are all greenhouse gases, but how you know that it is increasing? We have few observations, observation using instruments starting from 1950s or so. But before that also, so this graph shows the observation for last almost 2000 years. You can see that red is carbon dioxide, green is methane, black is nitrous oxide, the unit is parts per million it's called. And you can see that for many years the observations, the concentration used to be same, just a straight line. But recent few years you can see how sharply all this concentration has gone up, and mainly because of our activities, mainly because of industries. Started from after the Second World War, our industry has prospered because all countries, developed countries, came to know that during the experience of Second World War, they have to develop industries for many applications. So industrialization has increased during 50s, and that has really caused more increase in carbon dioxide, methane. Then our transport system, we buy cars. One family in the US, they have 3 or 4 cars. Cars emit carbon dioxide and nitrous oxide. Methane is mainly produced by agriculture because population has increased, so we need more food. More food means more agriculture land, and more agriculture land means more methane. So these are all mainly caused by our own activities, our own survival. We increase these greenhouse gases. Now, question is how we know this 2000 below about 1500 years, how the carbon dioxide measurement. I say about 270 parts per million. How you know? The answer is, what we do is we go to Antarctica and drill a hole and take the ice core, and how much you can go down will tell you how fast we can go. For example, if you take a ice core about 100 meters down, you can measure the life of, we can go back almost 2000 years back. And what we do is we bring the ice cores to the lab and do kind of analyze how much carbon dioxide molecules are trapped inside. So we can calculate the parts per million concentration. If we go about 500 meters, we can even go up to 10,000 years back. So this is the way we do it. There is one institute called National Center for Polar Research in Goa, where we have an ice core lab. If somebody is interested to see how the ice core is kept, how they measure this carbon dioxide measurements, you can go and see. It's a very difficult job. Going to Antarctica itself is a tough job, and drilling a hole and bringing it back without damaging, etc. is a big issue. So, but we do it very carefully. And this is the observation which we started in 1950s. There's a famous person called Charles David Keeling. He started the first carbon dioxide measurement in a place called Mauna Loa. Mauna Loa is in Hawaii, Hawaii Island in US, and it's a very it's a big hill mountain, and there they put the observations, and you see that how the carbon dioxide has been changing, increasing with the time, mainly because of our activities. So what I told is there are greenhouse gases in the atmosphere, and the concentration of greenhouse gas is increasing mainly because of our activities. And if you increase the carbon dioxide, increase in the greenhouse gases, it can allow it can stop the radiation, some radiation which is going out to the space, so we get more energy into the system, so that leads to global warming. And we have aerosols, there's different kinds of effect it has. Now so temperatures may go up, but do we have observation to see that temperatures are going up really? The answer is yes. So you can see if you take the 94, the bottom one, you can see 94 to 2023 data if you take and do a kind of analysis, trend analysis we call, you can see everywhere it is warming up, everywhere. The whole globe is warming, and warming trend is given below how much degrees Celsius per decade, etc. And you can see that more red is seen over Arctic region, North Pole, and so the warming is not uniformly distributed, it is distributed very asymmetrically. Northern pole is getting more warming than any other place. So I written in the right hand side, global warming for past 30 years is much faster than long-term trend. Warming is not uniformly distributed around the globe, And also land is getting more warmer than oceans because land is heat capacity is very small. Given energy, it can warm up, it can increase the temperature much faster than oceans. And Arctic region is warming much faster than any other region. So what is the repercussion, what is the implication of Arctic region warming is, Arctic region is full of ice, it's called sea ice. So sea ice is getting melted. And September is the month where you get lowest sea ice. But if we take last 25, 30 years of sea ice data and measure and see how the trend is, it is decreasing every year. And the models are suggesting, which I will talk about a little later, our climate models are suggesting that Arctic Ocean by 2050, almost 25 years later, in September, October season, we will have an Arctic Ocean without any sea ice. You can just imagine. Sea ice is the major component of the climate system of Arctic Ocean. By models are suggesting if the sea ice melting is happening the same way what we see now, by 2050 or 2060 we will have an Arctic Ocean without sea ice. And as a climate scientist, I am worried because sea ice has a specific work to do in the climate system because it can reflect the solar radiation. It has a high reflective power. Ice has a reflective power. Any amount of solar radiation coming on, it will reflect back. So it has a cooling effect. But if sea ice is melting, that cooling effect will be reduced. So it has a serious repercussions. But whereas countries like China, US, Russia, they are very happy because if ice is melting, they can do much more business over Arctic region. Ocean will be wide open. They can many ships can go ply. So if China wants to go to Europe, they need not go down Singapore and Suez Canal and go in a longer route. They can go very short route. And European countries are very happy because they can go down to the ocean and take whatever resources available, minerals, etc. So they are also happy. Poor man like me is worried because of climate change. It can really have a serious effect. So that is the situation now. Okay, this is the way how the global temperatures are increasing. You can see a sharp increase. And last year was the warmest year ever recorded. We have data about last 150 years or so. So you can see that last year, 2023, is the warmest year ever recorded. You can ask me a question, what is the global average temperature? If we take temperature measurements throughout the globe and average it for all the months, what is the temperature? It's about 14 degrees. 14 degrees Celsius is the average temperature of global. School students should know. The whole global average is 14 degrees. And this 14 degree every year is not same. Some years it will be 13.5, some years 14, some years 14.2, 14.5. But the trend is going to be in the positive side, 14.2, 14.5, 14.6, mainly because of the global warming. So, impacts of climate change. If climate change is happening and global warming is happening, so what? So the repercussions or impacts are plenty. One is on monsoon, which I will describe a little later. What is the impacts on monsoon? I told what do you mean by monsoon and why monsoon is important to us. And it has an impact on health. For example, heat waves which we see in April, May, June season is very, very deadly heat waves we get and many people die. And 2015 about 4,000, 5,000 people died only because of heat waves. And vector-borne diseases, malaria, etc., can be increased due to global warming or climate change. As I said, agriculture our climate has a big impact on agriculture. So agriculture practices, agriculture operations, crop yield output, etc. can change because of climate change changing. So they need to find out climate resilient agriculture. Water, as I said that water is very important. So in the future climate, water can be affected, water resources can be affected. Water stress could be there. More temperature means more evaporation, so water will evaporate up and that can affect our even drinking water. Energy, more temperatures means more energy demands. We will have more air conditioners, more coolers. The energy demands will be high. Disasters can be largely, it is can increase. I'll talk about few slides about what we have seen about monsoon. As I said that monsoon we get about 87 centimeter of rain during June to September, and as I also told that it is not uniformly distributed. Along the west coast it is more, northeast it is more, Rajasthan it is less, and central India it is little medium. But as all of us know that we experience every year, it doesn't rain all 122 days of monsoon season. So in June to September, it doesn't rain all 122 days. It rains only few days, even in Goa. Goa, of course, number is very high. But if you go to station like Solapur, Pune, or even Trivandrum, it doesn't rain all 122 days. It rains in few days, and we call rainy days. Those days are called the rainy days. And even in a rainy day, it doesn't rain all 24 hours. It rains few hours. The question is, how many hours it really rains? That was the question we used to ask ourselves, and we found the answer. So out of 322 into 24 hours is a big number. Many places they receive, for example, this is the map which shows how many hours it rains in a day, in a particular season. Or Ahmedabad, places like Ahmedabad, Jodhpur, Sholapur, etc. Out of 122 into 24 hours, they get only 100 hours rains. Whole season. It rains only in 100 hours. Remaining all hours is dry, there is no rain. And another, so along the west coast of it rains more. For example, Goa it's almost 600 hours it rains. Northeast also about 600, 700 hours it rains. The question is, so even station like Tamil Nadu, eastern parts of Tamil Nadu, the number of hours is less. And out of this 100 hours also, it is very interesting. Half of the rainfall comes in small number. In Ahmedabad, for example, it rains only 110 hours in a year, in a monsoon season. It's about 79 centimeter they get every year, 79 centimeter. And out of that, half of the rain, about 40 centimeter, it rains in just 20 hours. Only 20 hours are required to fill up that half of the rainfall. You can see how the rainfall is distributed. Very, very. So when it rains, it comes in big rain amount. And remaining rain and all coming by 2 millimeter rain, some 3 millimeter rain. So it is very important for water conservation. And when it rains very heavily, the rainfall will simply flow off, and we call runoff. No water will be allowed to stay back. It will simply flow. Especially when soil is already wet. There's no way the water can go inside because it will be saturated. So all the water will be simply flowing out. And millimeter rain, 2 millimeter rain, 3 millimeter rain, before it comes to the ground, it will evaporate. Okay. So this information is very important for water resources management. I will tell you, many of our water resource managers doesn't know this basic knowledge. They assume that whenever we want, we will get rain. It's not true. Okay. So, because students are here, so I want to request the students, you have to conserve water. Assume that water is very precious. Don't waste water. You use water only if it is essential to use it. Otherwise, don't assume that water is freely available to you. As I said, we are lucky that we have monsoon, we get plenty of water. But water is not to be misused. Water is not to be misused. You have to be very careful in using water. But that does not mean you should not drink water. You should drink an adequate amount of water, otherwise you will have serious problems. Drink water, but don't misuse it. Don't throw it out. Don't allow the water to flow out, etc. And how this monsoon rainfall is distributed is very difficult to explain. But one basic assumption, basic inference from here, this diagram is monsoon is a robust system. As I said, that we have a very robust monsoon. It changes every year. One year you will get good rain, some year you will get bad rain, we call drought years, and again some years you will get good rains. But monsoon is stable. We get some amount of rain. Minimum amount is about 75% of rainfall we can expect in a particular worst case. And you can go up to even 120% of rain you can expect. So monsoon is very robust, and monsoon comes on a particular time and goes back. So monsoon comes and goes. and it rains some amount, it goes. So we are lucky that we have a robust monsoon system. But within the, if you take last 100 years, there are years in which you get more, some years you less. All these red color bars are years where we call monsoon droughts. For some years like 79, 72, 87, these are all droughts. And that must have really caused serious impact on Indian GDP, Indian agriculture, Indian GDP. Years like 72, for example, it has caused severe. And 18 is the worst drought we had, the whole observational data, 18. And 18 we had even famine, people did not have food to eat. People used to die in 1918 and all. But now even a drought happens, that famine or the lack of food is not happening. Mainly because we are improvised ourselves, we know how to tackle a drought now. So drought still happens, but the impact of a drought on general public is very limited now. So many years, you people, we common people may not know there was a drought. Only government may know, because government is now able to manage the impacts of drought without harming our common people. But years like 1980, even 1972, we had serious problems. Many people died, starvation, etc. And another thing is, as I told that in monsoon season, I have another 15 minutes or so. So I'll quickly complete. And so, as I said that in monsoon season, it doesn't rain every time the same way. Some rains are very heavy. And these are the places where you can expect very heavy rains. And that frequency is down, you can see the frequency of heavy rainfall also is increasing. In a particular year, if earlier we used to have 10-15 heavy rainfall events, now we are receiving 25 to 30 heavy rainfall events. What is the implication of the heavy rainfall? It means if it rains more, it rains in very small hours, so it leads to flood. We call flash flood or something. And this rain consistently rains in 2-3 days, we'll have a river-based flood. It's called riverine floods, and that can really damage people. It can cause problem to the crops, etc., agriculture crops, etc. So, and you must have, this photo, I don't know how many of you remember, this is 2013 Uttarakhand flood, where 2,000 people died, it seems. And that is caused by a weather system. And if you really see the frequency of such rainstorms, we call, the frequency of rainstorm also is increasing. I'll skip all these things. And no, next question is, this is all we observe. Heavy rainfall is increasing, and drought is happening, and etc. So what? So what will happen to the future? So next 20 years what will happen? Next 50 years what will happen? Next 70 years what will happen? So we have called this a future monsoon projections, we call. And one thing we can do, we can go to an astrologer and find out what will happen, sir, what will happen after 20 years. He may tell something. But what we do in science-based projections we make, and we call the models, we use mathematical models to make projections for our future climate, and we call that models are called Earth system models. This is the model will treat all these things which is happening in the Earth system. These are the different physical process which is happening. Clouds are forming, rain is happening, so many things happening. So these are all to be treated in the model. And these are the two people, because you are all science students. I want to show these photographs of these two gentlemen who got Nobel Prize in 2021. They are the pioneers in climate modeling. One is especially Manabe, who is basically a Japanese citizen, now but he works in US now. And another is Hasselmann, he is from Germany. These are the two people who did pioneering work in climate modeling. And I'll show you an example how good our climate models are. In the bottom there are four maps, and out of the right-hand side, bottom right-hand side is the actual satellite photo of cloud on a particular day. You can see there are a lot of clouds over Africa, and from Antarctica also there are a lot of clouds. In the Pacific also there are clouds. And left-hand side is the model predicted clouds. You can see that how accurately the model is able to predict the whole structure of, beautiful structure of clouds. That model is run at 1.4 kilometer resolutions, very high resolutions. But for that, you need huge computing power. And we have brought a new book when I was secretary in 2019. This book will give if you really want to know about climate change and what climate change has seen the impact on Indian system, you can read this book. It's the first national climate change assessment which our ministry has brought out. And so you can see that how many downloads are, 378,000 downloads are there. I insisted this book should be open, it should be free of cost. So we paid to the publisher, Springer, about 40 lakh or so, and told them, we publish this book, but keep it open. Anybody can download it. So people are simply downloading and reading it. Any scientific information which we need to communicate to the public in large should be available free of cost online. So that is the message which we gave, and it is very successful. And the question is, what will happen to future monsoon? This is the right hand side. You can see that during future climate, our monsoon rainfall is going to increase. So it's a good news. So we will have a good monsoon in the coming years. But bad news is we will have more and more intense precipitation. Heavy rainfall events will increase in future. For example, 5-day total precipitation. For example, 95% rainfall. So monsoon rainfall will increase, total amount, seasonal. But inside the season, we'll have more and more frequent heavy precipitation, and that will lead to floods. This is the same thing which we clearly show. I will not skip this. And also, it's not only floods, we will have more droughts also. So both the end, even this side, left-hand side also, right-hand side also spectrum, we have both the things. It is going to increase. We will have more rain, more heavy rains, more floods, and here more droughts. Both will happen. This is all I will skip, I think. And also, as I said, that increasing risk of droughts is going to happen. And this diagram I will show. Assume that we don't do any corrections in the increase in the greenhouse gases, and that temperature will go up to 2-degree warming can happen. Okay, this 14 degree can go up to 16 degree. That's the meaning. That mean temperature instead of 14, it will go up to 16. But the implications will be very huge. You can see the bottom on the slides. You can see the people who are affected of extremes because of 2-degree warming is almost 300 to 400 million people will be affected. And that will increase if global warming also increases. So if we can retain the warming up to 1.5, then we will get around 250, but if it goes to beyond 2 degree or so, around 400 million people. And this is the area where people will be affected. You can see the rightmost thing, and which includes Goa and the western parts of India, and only the small portion of eastern parts of India is not much there because many people are not living there. It's a Maoist region, so it's a hilly region. There are many people are living there. And this is 2018 Kerala floods. I don't know how many of you remember 2018 Kerala floods. And many people are told that it was not well treated. The floods happened. Many people died. A Malayalam film also was made, and it went to Oscar. Oscar did not bother about 2018 flood, the film. They did not give anything to that film. But the story is, in the future climate, if the same kind of weather system forms, it will be 36% heavier than what we experienced in 2018. That is the message. That means when the same kind of weather system forms and rains in Kerala in maybe after 20 years or 30 years, it will be 36% heavier. And the paper they wrote one more sentence, which I am not disclosing here, which I have not written here, is the present dams in Kerala will not be sufficient to withhold the rains which is coming out from that system. 36% heavier rain. Dams will not be sufficient to control that bottom. So much rains will happen. So this is the lesson to any state government. And these are the very important things that are happening. So far I have been talking about monsoon, but this kind of very serious things are happening at many places. We call climate tipping points have been identified. And climate tipping points is nothing but point of no return. It will not come back. It is gone to that side. One is Greenland ice sheet. Arctic sea ice. Arctic sea ice is the most important thing which is happening now. Atlantic circulation, ocean circulation. Amazon rainforest is depleting every year. Boreal forest, coral reefs. Coral reef is a beautiful system, marine system in the coast of Australia that is going out. West Antarctica ice sheet, permafrost. So all these are some of the things which they identified. They say that if you don't take any action now, it can really cause damages to the system and it cannot come back again. They have serious problem. So these are a summary of things. As I said that with the global warming, monsoon rainfall is likely to increase, frequency of extreme precipitation likely to increase, duration of monsoon likely to increase because withdrawal is getting delayed, dry spells will increase, and so and so. So question is, we know these are all caused by global warming and it's all caused by increase in greenhouse gases, and most of these greenhouse gases are emitted by us. Increase in the greenhouse gases is caused by us. Question is what we can do. You must have heard, I don't know how many of you heard about Paris Agreement, which we made in few years back. It's a climate change Paris Agreement. The Paris Agreement, all countries have agreed that this warming will continue, and this warming we should restrict up to 1.5 degrees Celsius only. And but many countries are not following that. So what to do? If you want to keep it 1.5, whatever we are emitting in the atmosphere because of the emission of use of coal, petrol, gas, etc., should be reduced. Then only this greenhouse gas concentration will decrease. And so for that, this is the map shows how the extreme rainfall is increasing with respect to time. You can see that huge number of extreme rainfall is extreme events are happening. Flood, drought, extreme weather, extreme temperature, etc. are happening. So all countries have agreed to have some kind of agreement saying that we will reduce our emission of fossil fuel. Fossil fuel means coal, basically coal, petrol, diesel, etc. And these are all big emitters of greenhouse gases now. US, China, Europe put together we call European Union, Australia, and India also. And India is basically, India contributes about 6% of carbon dioxide emissions from fossil fuel. We are at third place after China, US, and then third is India. But per capita emission is very less. That is shown here on the right hand side. Per capita emission means how much is emitted in gigaton divided by population. So that comes very small. That means per individual we produce less carbon dioxide because we don't use so many vehicles, we don't have a luxury life. Whereas countries like Canada, US and all, per capita emission, Saudi Arabia for example, UAE, because their lifestyle is different. One house there will be 4 or 5 cars. Together they will use. So per capita emission is very small in India. And so, but per capita emission like countries like Canada, US and all. So basic polluters are Europe, basically Canada, US, European Union, Australia, China. These are the countries, big polluters. So they have to reduce their emissions very well. So we have made an agreement called net zero commitments. That means whatever we are emitting should be absorbed back so that there will be no further increase in the carbon dioxide gas. And that is, if you ask me a question whether it is really going well, the answer is no, it is not going well. That agreement is not being followed by all countries. And but India is very committed. India at present about 49.1% of India's energy requirement is coming from coal. Coal, if you burn coal, carbon dioxide is emitted. So that means coal is not a good fuel to be used. So our Indian government is committed to go for more renewable energy, like wind energy, solar energy, biogas, nuclear energy. These are all called renewable energy or new energy. And so we are trying to go on, and now over 67% of renewable energy is coming from sun, solar radiation, solar energy, 42 is from wind. Another aspect is if carbon dioxide is emitted into the atmosphere, can we take back some carbon dioxide and put it somewhere else, reduce the carbon dioxide? So this is all we call geoengineering. It's a new area of research. Nothing is seriously done, but serious thinking is happening everywhere. And there are many options in which we can do geoengineering and reduce the concentration of carbon. carbon, we call carbon capture or carbon geoengineering, and reduce the warming. What we should do is, whatever solar radiation coming and whatever going out, anyway going out cannot be increased because already we have greenhouse gases. Question is, can we reduce the solar radiation which is coming inside so that our net energy will be zero? One option is putting big mirrors in the outer space, the very higher atmosphere, about 10-15 kilometers, so that when solar radiation coming, it will reflect back and we will get less radiation. This is a very dream project. It can have, it's very difficult, it is theoretically yes, difficult to implement. But I am very sure Hollywood will come out with a film next 2 years that they will, once a hero will go up and put some mirrors and solar energy is reduced and they leave thereafter, they leave very happily. But implementation is very difficult. Another thing is, in the clouds, there are clouds, you put more sulfate aerosols and that sulfate aerosol will increase the reflectivity of the cloud. So more solar radiation can be going out. And another thing is, you capture carbon dioxide through some means, put it into liquid form and pump into the deep earth. Wherever these old coal mines are there, just pump it inside and it will lie there. Another is, oceans absorb 50% of carbon dioxide which we emit. So oceans are very important. Forest green cover is very important. So increase the green cover, increase the forest cover. Put more and more trees, that will increase, it will absorb so more carbon dioxide. Now, ocean also, as I said, 50%. The question is, can we make this 50 into 55% or 60%? So more carbon is captured by ocean. It's possible. What they do is, right inside this written, algae. The ocean, there are algae. So increase the amount of algae. Algae will absorb carbon dioxide, it goes down and goes to the bottom of the sea. And so carbon also will go down and it will lie in the bottom of the sea. These are some of the options. Many theoretical studies are happening, but physically nothing is really happening. Because it's a very complex process. The engineering process is very complex. But we are all trying to do, because global warming is happening, it can have a serious implications. I will tell you, it's not a story told by grandmothers to grandchildren. It's a real fact is happening. And because it is all caused by our own activities, so we have to control ourselves. It will have serious implications. It will have floods, it will cause heavy rains, heat waves, so many things. So we have to be very careful. But I'll tell you that nothing will happen today night. So please be happy, sleep well, eat well. Wish you all the best. Thank you very much. Any questions if you have, I will be happy to answer. Any questions you have?
So my question is not related directly to climate, but it is regarding the EV vehicles.
EV vehicles?
Yeah, because Indian government is pushing up for EV vehicles, which has something to do with lithium batteries. So will it affect climate change?
EV vehicles are good because we are trying to go out of petrol and diesel. So more of batteries. So it will not. So if you put to use petrol or diesel, then it is basically generating more of greenhouse gas. So we are moving into EV vehicles. But moving into EV vehicles is not very easy task. First of all, EV vehicles are now very costly. We are not really perfected the technology, but we have technology, but we have to reduce the cost of EV vehicle. So I urge, in US, Tesla makes all EV vehicles, and Tesla car is used extensively in US. So we will also, after maybe 4 or 5 years, we will also have EV vehicle. EV vehicles is good. So if you have enough money, please buy a EV vehicle instead of a petrol vehicle. EV vehicle don't have any serious impact on climate.
No, but so my question is regarding the lithium batteries. Means
lithium batteries.
How those batteries will affect?
Yeah, lithium batteries. Lithium is not freely available in India. So we have to import it from outside, especially from China. And I think countries like Peru also uses. So that is a real challenge. We don't have good technology within the country to make lithium batteries. That I agree. So, but that's why cost is very high. Because we have to import the batteries and do it. But we have to finally move to more of electric vehicles than. The question will come again. A question comes in, even if you use electric vehicle, you use ordinary electricity plug point to charge. Yes or no? again, from where the electricity comes, again, electricity is produced um, by some other non-conventional sources. So that's the answer.
So the question is, to charge the lithium battery, we need electricity. And if you see the scenario of India, most of the electricity is produced through coal.
Yes.
So
I agree. To charge the lithium batteries, you need electricity. That's what I was telling. And from where the electricity is again produced.
so again, the fossil fuel has to be burned.
So what people are trying is, for charging these batteries, we should use non-renewable energy to charge, like solar or wind panels we have to use to make the charging points where the EV batteries can be charged, not typical electricity. That is possible. That's what people are now doing it.
So I have one question. All countries are doing whatever possible to arrest the impact of climate change. Every country literally is doing, some are doing more, some are doing less. Now in such scenario, there are wars happening. So we have war happening in Russia, we have problem there in the Middle East. How this would impact climate change? So whatever positive things that we have done, how it will turn our positive into negative? That is basic question, meaning our efforts will go in vain.
So that's true. That's a good question. So, but I will tell you, all countries are not purely committed as we really want. For example, America is not. They are not purely. For example, Europe, Arab countries, they are not very committed to reduce the fossil fuel because they survive by selling the petrol, isn't it? Countries like Saudi Arabia, UAE, they have to survive by selling petrol. They don't have any other source of income. So they will not support this kind of Paris Agreement and all these things. Only very few countries are committed. And what they say that if you reduce the fossil fuel, like coal or petrol, it will affect their development. They have to develop. That is true. It will have an impact on development. For example, if they want to make a city, if they want to develop a new kind of new environment, you need energy. Energy is a primary source. And they don't want to reduce fossil fuel because their development, it will affect their development. India also same thing. India also need a development. But India also but India is more committed to reduce the fossil fuel and go into non-conventional energy like wind or solar energy. We also need development. The difference between the development between these two countries is developed country, for them development is luxury. For us, development is minimum survival. That is the difference. Both the countries have a needs development, but for them it is a luxury, for us it is a mere survival. And this kind of wars which is happening now will have a serious implication on the negotiation which we do on climate change.
Yeah, Namaskar sir. I congratulate you for a very nice lecture. My question to you is, you have said the rainfall time is not known to the planners and all. How much time it is raining, 100 hours or 110 hours, and they lack in planning. So what efforts will be taken to?
So this information is passed on to many ministries, many water resources people. But my point is that when they make a kind of a projects, when they develop a strategy or working plan or white paper on water resources management, this kind of information is not kept in their mind. So they are doing it assuming that water is available anytime.
Yes, sir.
Which is not true. Water is available only few hours. And when that few hours are missed, we lose that opportunity to save that water. So that is a message. But I will tell you, many farmers don't know about it. Many big planners don't know about this. So we are trying to teach them. We are teaching them. Slowly things are changing, but it will take time. But my point is that this kind of very basic things are to be told to the people so that when they make the strategy, they have to keep these things in mind.
Yes, thank you, sir.
My question is, what if we replace, instead of coal, we use hydrogen in thermal power plants? What would happen to the climate?
What is your question? Instead of coal?
We use hydrogen.
So now green hydrogen project is coming. With the hydrogen we can generate energy. So green hydrogen project has come out. Government has given kind of approval for I don't know how many crores of rupees. So Indian ministries, DS Department of Science and Technology, and many industries are trying to do green hydrogen technology. For only thing is, what I was told is that it is very difficult to transport green hydrogen from one place to transport systems will be very complicated because hydrogen is a very inflammable gas. It can catch fire immediately. So we have to be very careful. But the source of hydrogen can be used as alternate energy, which the government is doing it now. It will come out. Maybe another 4 or 5 years, we'll have green hydrogen energy sources.
Yeah, thank you, sir.
It's a good question.
We thank Professor Rajeevan for that insightful and informative address. Thank you, everyone, for joining us today.